well, for those of you that aren't here and you're watching this recording, we are a little bit late getting started, but not to worry. Our presenter will be here in just a moment. I am Kyla and I am with Kids Co Jeunesse. So I'm the moderator for today. But I can give you folks a little bit of a spiel, if you will, about who we are, what we do, and what we're going to be doing today while we do wait for Kai to join us. So Kai is going to be the instructor. Kyla is here. Oh, I see Kai has joined us here. So Kai, get all the stuff set up on your end. And I'm just going to give a little bit of an elevator pitch about KCJ while you're getting yourself oriented there. So folks, we are Kids Co Jeunesse. We are a national organization. We do have global reaches for sure, but we are in Canada, right across the country. That's why we've actually had a few technical glitches with this conference today due to time zones. We are a bilingual organization, so all of our offerings are offered in both English and French. And we have a real dedicated focus on teaching kids how to code, how to interact with their computers responsibly. We're the first organization to really dabble into artificial intelligence, which we'll be talking about today. We have a focus on girls and underserved communities, but we do offer workshops right across the country, both in classrooms, in the community, teacher trainings, the whole kind of 9 yards. Whatever we can do to support educators and their beautiful students in classrooms, we will certainly do that. We have for grades 7 to 12 upcoming immediately in September. It's actually open now for you folks. We have Code in the Classroom where you can book a live workshop in your classroom. It's going to be done virtually, of course, but it's with a live instructor. There's some options there. Lots of really cool workshops for sure. And yeah, we just feel we do whatever we can to support the educators in our community as we support our students and the future generation, of course, being able to access the world around us now, which is very technology heavy, and getting them to understand. I always say that knowledge is power. It's a cliche, but it's very much true, especially with the work that we do. Yeah, so Kai, if you're ready, I can turn it over to you. But for you folks, I am Kyla. I'm going to hang out here in the chat. So should you have any questions whatsoever, you can certainly drop those by, and I'll either interrupt Kai if there's something super pressing, or I will answer them in the chat, and we'll just have a real nice session here today. Kai, I did send the Predictipy link in the chat to these fine folks to have a look at. I'll send it again there, but over to you. Oh, you are muted.
There we go. Yeah, so thanks for having us in, everybody. Glad to be here this morning. So Kyla's given a bit of a introduction there already, so I'm just going to jump ahead into our session here. Sorry, I'm a couple minutes late. Yeah, got time zones switched up there. I thought I was presenting in an hour, so oh well, but we're here now. So yeah, thanks for having us in. So today we're doing a workshop called Predictipy. So what this workshop is all about is learning about neural networks. So these are a particular type of artificial intelligence or machine learning system. And so fairly obtuse subject here. So we'll explain what that is and how it works, and give you actually some hands-on experience with that kind of technology. So we'll explore a little website tool that we've helped create to work with neural nets and really see how they're working. But importantly, we also want to tie in why we're learning about artificial intelligence into broader curricular connections with, whatever jurisdiction you're teaching in, as well as the SDGs, or Sustainable Development Goals. So this is something that we try and use at KCJ to guide our development, so that we're not just teaching kids information, but we're also teaching them to learn fundamental skills and techniques and technologies that they can use to make a better world. So the Sustainable Development Goals are UN global goals, to build a better world. So how do we connect what we're learning with those larger, broader goals so that the students we teach are prepared to build that future world? So our sustainable development goal for today is number 4, quality education, ensuring inclusive and equitable quality education and lifelong learning opportunities for everyone. So really learning about AI is all about making sure our students are able to operate in the world that they're going to be adults in. So AI might be very new technology. It might be very remote, obscure, unfamiliar at this time. But when our students are actually out there joining the work world in 10 years, it's going to be an absolute, undeniable, inescapable part of life. And if they don't understand it, they won't be informed citizens. So we have to make sure that the digital competency and digital literacy are there to ensure that they're going to be able to operate in the world that they're going to live in. So curricular connections, we can talk about the broader societal impacts. We can discuss ethics. We can discuss all sorts of social studies impacts on communities and global community itself. We can, talk about digital skills and ensuring that those practical skills, career skills, are up to date. And of course, anytime we're dealing with any kind of computer technology and computer science, we can talk about computational thinking, design thinking, and general computer programming or computer science. So, AI doesn't necessarily always involve computer programming. It can be more of the end user, just seeing how the systems work, not having to program them yourself. But you can still think about the processes and methods that are being used by computers and computer science to manage and manipulate information. And that has all sorts of broader curricular connections and potentials. So today, what we're trying to do is understand the concept of a neural network, its components and its mechanics. We're going to build and modify our own neural network today, which sounds like a pretty high benchmark for a 1-hour workshop, but we will actually be able to do it. And we're going to talk a little bit about some of the ethical issues related to model transparency and the methodology used by any given AI system. So those are our learning objectives for today. And so why are we talking about AI? So here we've got a little timeline of some of the radical innovations in industry that we've had to deal with in the past a little over 200 years. It starts with just the very first, industrial revolution steps there with mechanization and steam power. We saw things adapt to assembly line and electrification. We've seen automation roll out more recently. Now we're moving into the Internet of Things and web connectivity concepts. And the next big step is going to be AI, is taking those automated systems and making them able to predict and adapt through AI technologies like neural networks. So this is going to be as large a change to industry as automation was, as electrification was. The scale of change that we're talking about is enormous. Different reports that you'll see have ranged between estimates of 25% to up to 70% of jobs being displaced by AI within 30 to 50 years. So that scale of change is simply unimaginable. It's going to change society so drastically that we really can't even wrap our heads around it. What happens if robots are doing all of our jobs? what if you never see an employee at any fast food place, at any manufacturing factory, at any mine? What will society look like? It's so shocking and drastic that we really can't understand and predict what society is going to do. But that's the scale of change that this technology allows. So this is one of the reasons why we have to have these conversations with students, is because the world is going to be changing so drastically over the next coming decades that we need to be having those conversations. We may not know the answers, but that doesn't mean we shouldn't be having the conversation, because all we can do is predict. All we can do is attempt to come up with some understandings, predictions, appreciations of what the change might be, so that we can adapt as it's happening if we can't adapt ahead of time. So this really is quite a drastic and revolutionary technology, and that's why it's so important that we start wrapping our heads around it. So we're going to start by working with a pre-trained model. So this is essentially a neural network that we've already built, and we've trained it with some data so that it can already do a certain amount of work for us. So neural networks are developed off of the concept of how our brains work. Our brains are built up of millions of neural connections, neural roots that allow signals to transit through the brain. They bounce between different points, different neurons in the brain, and each neuron basically can do a tiny amount of decision making, but it's in a network that it allows it to handle complex tasks. So one given neuron may decide whether to fire or not on a very simple little basis, but when you have millions and millions of neurons firing, you get complex thought patterns. We still don't entirely understand the brain, so it's a little strange trying to use the brain when we don't really know how entirely it works and creates consciousness. But the basic principle does hold true, that essentially if you have a complex problem, if you can break it down into small components where you can make easier, smaller decisions, and you can chain those small decisions together, you can try and come up with more complex predictions based on those tiny individualized facts and decisions. So what we deal with are, in this case, an amount of inputs. With humans, this would be, sensory input, what we see, what we hear, etc., creates this input data. And then we start processing that input data through our neural nodes. Here on the chart, these are marked sort of hidden decision-making patterns. So certain input data goes to certain decision nodes, and then a decision is made there, and it feeds into a further chain of outputs. And here you can see sort of way more arrows point to this output than this output, so it's the more likely candidate, right? So it's a very vague concept of decision making, but as we start working with it, it's going to make a lot more sense. So to work with it, we're going to go to a website we've helped develop here called Predictipie. And this is a neural network that we've made to guess what kind of pie it is based on the ingredients that are in it. So we can go to predictipie.glitch.me, and you should see this website. So I'll give folks a minute here to go to that link. I believe Kyla's posted it there in the chat a couple times for you, so hopefully everybody has followed along. So here we can just see a little landing page that talks about the project. So we worked with STEAM Labs in Toronto, and Amazon Future Engineer gave some funding for this. And it explains a little bit about neural networks there. But we're going to get hands-on right away here. So if you go up to the top left corner, you're going to see a little icon of 3 horizontal bars. And if you click that, you get a little pop-up. And first of all, actually, I'm going to create my own little classroom here. So everybody in this workshop, you're going to join the same classroom as me so that we can share data between us. Okay, so I'm going to create a classroom, and when I do this, so this is something you would do for your own class when you're exploring this. I'm going to create a classroom, and that's just going to generate a single keyword for us all. So our classroom code is sugar. Okay, so sugar. So when you click on the horizontal bars, you can click join a classroom and just tell it sugar. That will allow you to join the classroom that I'm in, and then we're going to be able to share the statistics that we generate using this neural network. It'll let us see the results that we're all having. So it's decidedly better having more users in the same classroom because you're getting a lot more people feeding data in. If you're just doing it by yourself, you'll probably already know the results because you were there for them. But if we all join in the same classroom, sugar, we can see some more statistics when we're done. So after you've joined your classroom, we can go back to that menu and we're going to select test a pre-trained model. So this is the neural network that we've already built and trained. We've given it a bunch of data to analyze, to make predictions with. And we're going to see how that works. So click test a pre-trained model. And oh, somebody's been adding another one. Okay. So we're going to just select PredictAPI. And that will take us to our neural network here. So on the left-hand side here, we can see a whole bunch of different ingredients. And then in the middle, we can see a bunch of unknown neurons where there's a whole bunch of connections going to them and then some connections leading out from them to a second column of neural nodes. And then on the right-hand side, we can see the different categories of pie. So there are sweet pies, there are quiches, there are pizzas, there are savory pies, and there's other. For anything that isn't those 4 other categories, we just have that catchment of other. So we can see all of these different ingredients, and somehow, whatever combination of ingredients you use is going to be some kind of pie or other, which may or may not be a pie. So what we can do is we can test out our neural network because it's already been trained on some data. So we can just have some fun with this and see it in action before we start here. So up in the top right-hand corner, you're going to see the word random and find recipe button there right beside it. So random is just a category of recipes it will automatically generate. And if we click find recipe, it's going to make a random recipe for pie by selecting a random set of ingredients. And then it's going to take that random set of ingredients and try and guess what kind of pie it is. So just click on find recipe and we'll get a random selection of ingredients. So in this case, it's selected for me: crust, onion, blue cheese, and egg. So if I were to put egg, blue cheese, onion mixed together into a crust, what would I call that? And the computer here, you can see there's now green lines connecting the different ingredients to different nodes. And you'll see that the nodes have actually lit up in different colors. So some of them are still white, some are dark green, and some are light green. And you can chase all those different little connections through to our different categories. And it's selected quiche as being the most likely category for that combination of ingredients. And you'll see on the very right-hand side here a confidence rating. So it's 100% confident that that's a quiche. That's maybe a little more confident than it should be, but that there's its guess. And so there's this little pop-up that says, do you agree with this classification? So did the AI get that correct? What's your opinion? So I'm willing to go, sure, that sounds like a quiche to me. So I'll click yes. And that helps make our classroom statistics. So that's why I wanted us to all be in the same sugar classroom. So we're going to be able to share our stats and see how well the AI did or didn't do, depending on these different recipes. So go ahead and try it out yourself. Click, find some recipes, see how it categorizes them, see what the confidence ratio is. This one, it's very confident is a quiche. Sometimes it'll be way less confident. Maybe it'll only be 60% confident that's a sweet pie. So you can see how it thinks those ingredients line up with given types of recipes. So just play around, see what it's like, give it a few tries, let it analyze a few recipes and click yes or no to whether you agree with the classifications. And we'll see what our statistics are like after we try it a few times. So this time I've got a savory pie, crust, corn, broccoli, and soy protein. Well, I can definitely agree that's not a sweet pie, quiche, or pizza, so I think that's probably a good guess. You can also, instead of a random, you can try the other categories, so it will try to build a savory pie, a sweet pie, a quiche, a pizza, whatever you like. So you can try the different categories and generate them and see what you want, see what you get. That's definitely a combination I haven't tried. Cheese, chicken, pesto, and corn pizza. I'd be willing to eat it. So we give it a few tries, and that sounds very quiche to me. Okay, so after we give it a few tries, you can see what it's doing and approximate a little bit about how it's working maybe. But what we can do now is we can actually view our classroom statistics, see how it's doing with everybody's guesses. So if we go back up and click on the 3 horizontal lines again, we can actually take a look at our classroom statistics. So view classroom stats, and we're going to see that our classroom had 43 total predictions and had 41 correct classifications and 2 incorrect classifications. So we can see our accuracy rate, and down below we can actually see some of the recipes that it's been generating. So we can see the ingredient list, we can see the original classification that the AI came up with, and then if it needed, If the human user decided to reclassify that recipe, we can see what they reclassified it as. So here we can see crust, corn, onion, and ham was originally labeled as savory. The user decided to reclassify it as other. This one was crust, tomato, egg, and shrimp. So that got labeled as quiche. The human user decided that should be a pizza instead. So we can see there will be some disagreements with the classification. It's definitely not 100%. Either way, the AI can make mistakes, the human can make mistakes. Sometimes it's just a perception difference because you can use ingredients in different ways and different ratios. So it's not a black and white issue. Food is a very complex thing. So, but what you can see is some sense of how it's classifying, and if people are disagreeing with it, you may come across interesting specific recipes that trigger in different ways. You can definitely get into some serious classroom discussions over what the correct classification is for something. But if we go back to test a pre-trained model, we can play around a little bit more with our Predictipy here. So you'll notice that our ingredients are being selected, and on the very left-hand side, you can actually see a switch for them. So you can play around with the recipes by turning ingredients on and off to explore the ideas a little more. So this one happens to say quiche. It's got a crust, cheese, egg, and salmon. Well, what if instead of salmon, it was shrimp? It still thinks it's a quiche. But what if I turn off egg? It thinks it's savory, which is interesting. I was certain it was going to predict that would be a pizza. It's got cheese and shrimp and crust. I don't know, to me that sounded more like a pizza. Maybe it doesn't think shrimp is a very pizza ingredient. Maybe that's the issue. If it was ham, I'm sure. No, ham, cheese, and crust, it still thinks it's savory. I'll be darned. So maybe if I include tomato. There we go. Tomato makes it think it's pizza. So sometimes the combination of ingredients to you and to the computer won't be quite the same thing. I didn't think tomato was that critical for a pizza, but it apparently does. So that's an interesting choice on its prediction system. If I use pesto instead of tomato, it ends up as pizza. Okay, good. If I add egg, though, it doesn't become a quiche. Interesting. Very curious. So we can see that there's a lot of different options and hard to predict. Food is a very complex and cultural thing, which, let's face it, computers are not particularly very culturally aware. AI hopefully can become that, but it's not really an inherent strength of AI systems. But you can see basically we can select the different ingredients and somehow it's coming to a decision about what category it is. So how is it doing this? We know that there's those hidden nodes. We can see the colorizing of the lines and dots, and we can even see like the intensity of colors sometimes. So like this top dot for some reason is light green instead of dark green. So it's in some way slightly less of that versus one of the darker greens. And apparently you even get a number if you hover your mouse over a given dot, which I don't think I'd ever noticed that before. So you can actually see the value it's applying to a given category. Interesting. So we can see it thinking in some way, but what's actually going on under the hood here? So let's explore that a little more. So I've just run through a few of these explanations here. So we can see our stats and whatnot. But the real way to learn what all of this means is to build your own model. So what we're going to do is we're going to go back to the website. And if you go up to the top left icon again, you can see instead of test a pre-trained model, you can actually build your own neural network. So if we select build a neural network, you're going to see a new interface here where we can start putting together our own neurons and options, our inputs and our outputs, and we can add in layers in between. So I'm just going to stick with the Pi theme, so I don't have to fire too many of my neurons. I can just borrow what we were doing, and that'll help explain what we were doing. So, for example, I could add in ingredients on the left-hand side. So I can add egg, I can add in cheese, I can add in ham, I can even spell it right. And on the output layer, so on the far right here, we can come up with our categories. How do we want our AI to categorize things? To what decisions is it making here? So again, I'll use the some of the categories that we saw in our pre-trained model. So I'll just add in a few for now. And what we can do is there are little dots on our ingredients, and on our outcomes, there are pluses and minuses. And so what this is our given inputs have an influence on whether they positively correlate to an outcome or negatively correlate to an outcome. And all we have to do is connect those categories. So eggs positively correlate to quiche, and they negatively correlate to pizza. You're way more likely to find eggs on quiche than you are on pizza. Cheese is very likely to correlate to pizza, but it also correlates to quiche. And, well, ham would go in everything, so. Ham doesn't really help us make any decisions. So right now, with this really simple neural network, if we turned on ham, it's not particularly going to do a particularly accurate job of guessing, but right now it's the only thing that connects to savory. So if I selected ham, it's deciding it's a savory by default. If I select cheese, it can't really decide. It's equally split between quiche and pizza. If I turn on cheese and ham, then it appears it's pizza or savory and or savory at the same time. If I turn on egg and cheese, it's not entirely sure. If I just have egg on, oh, that's unusual. I would expect it to turn quiche on. I'm not sure why it's not. Intriguing. But we can see that certain things now create correlations in some very, very rudimentary way. I mean, this is not exactly in-depth analysis here, but it's showing us the basic principle of how we create a neural network. We're not making a good decision here. We're just making a decision. To make things more complex, we can start adding in, that's intriguing, we can start adding in more decision layers. So like we had in our pre-trained model, there were those columns of dots, and each of those is basically additional analysis that can be happening between our inputs and our outputs. So right now, we have a very basic guesswork of, just direct 3 inputs goes directly to the outputs immediately with no steps in between. Well, that's not a particularly good way to make decisions. So we've added some inputs, we've added some outputs, we've added some correlations. Cherries and onions would be a good example. Those are a little stronger than cheese. You can put cheese in anything. So you can see how we're making those connections. But if we add in some hidden layers, we can start making some better decisions. We're going to add some nuance to things, and we're going to create essentially some commonalities of features of our final decision. We don't have to jump directly to a final decision. We can come up with some commonalities towards a given output. So here you can see they've added in butter and flour as potential ingredients. And if you have both butter and flour, there's a good chance that you might be making a crust. Now, if all you're deciding is pies, chances are there's always going to be a crust involved. But if you're deciding between pie and cake, if they're making crust, chances are they're making a pie and not a cake. So sometimes those qualifications can help lead you to better outcome determining decisions. So you can see instead of just crust, maybe there's fruit fillings. If you can determine some commonalities between fruit fillings, then you're going to be able to more easily predict a sweet pie because so many sweet pies are fruit filled. So if you see sugar and some kind of fruit, they're making a fruit filling. If they're making a fruit filling, they must be making a sweet pie. You could have other commonalities such as maybe eggs and cream. If you're putting together eggs and cream, maybe you're making a custard. That leads towards guessing sweet pie. But it's also used in pasticcio or something like that. So it could be a savory pie still, but I've never seen custard on a pizza. So you'd be able to eliminate that category, right? So sometimes these intermediate categories that we can use by building those hidden layers can really add value to what we're doing. So let's add cream. Let's add a fruit. Banana, sure. And if we add in a layer here, we can add in some of those intermediate steps. So when we add that hidden layer, I can now add in custard. I could add in meat fillings. I could add in omelet. I could add in fruit filling. And of course, now we don't have our ingredients directly linked to our outputs. We're going to have our inputs linked to intermediate categories, and then our intermediate categories linked to our outputs. So this is where things get more complicated, but we can end up having some better classifications. So ham's always a meat filling. Cream could be in an omelet, could be in a custard. That's going to be sort of hard to choose between custards and omelets, because that's really just a ratio thing. But computers can analyze ratios. If they have that data, if you give it recipes, it can go, oh, there's a cup of milk or a cup of cream and 1 egg. That's not going to be an omelet. That's going to be pretty liquidy. So computers are really good for statistical analysis, And if you give them data, you can get them to do all sorts of statistical analysis to make better predictions. Oh, I don't have any sweet pie. So we know custards can be used in sweet pies, they can be used in savory pies. We don't find meat fillings in sweet pies. We don't find omelets in sweet pies. We find fruit filling in sweet pies. Okay. So now what if we put cream and bananas and egg together? It's not making a final decision, but it knows that it could be talking about custard or omelets or fruit fillings. So we need to tweak things a bit more before they're going to really make good decisions. And again, obviously, I'm not working with very much data here. This is just a start to introduce how you'd build it up. You're going to want to tweak things a lot more. But what we can do is we can also tweak how likely something is. So this is, again, something that you would derive in AI systems through just brute force statistical analysis, give it tens of thousands of recipes, and it can crunch all the numbers. But we as users, we can also influence things. So in this case, if we click, for example, our little plus icon where our inputs are coming in to a category, we can decide how likely a given choice is. So in savory, for example, I have the custard category leading to savory, and I have the meat category leading to savory. Well, how likely are either of those to actually go to savory? In this case, custard is pretty unlikely. There are actually relatively few savory custard recipes. There are some, so I want to have that connection, but it's pretty low odds. So I'm just going to rank it down to only 10%. Meat filling, though, is very common in savory pies. So I'm going to crank that factor way up. So we can do that to make things a little more sensible. When we select a category, we can see the rate of which that connection should be ranked. So here, I want to crank up omelet is just huge for quiches. I'll just max that right out. Meat is not as important for a quiche. There's plenty of vegetarian quiches, so I'm going to leave that sort of 50-50. But as we create those connections, we can influence how likely these decisions are. So custard is fairly likely to be a sweet pie, but fruit filling is like really certain to be a sweet pie. So interesting. I clearly haven't tweaked the numbers enough because it still thinks it's a quiche. Oh, I should put fruit filling as a negative towards quiche. There we go. That should help. So by influencing the weight that that decision, that connection makes, you influence the weight of the entire decision process. So obviously, it needs a lot more work to really get to a good usable space than I can do in a quick little demonstration here. But we can see the basic principles at work. So by creating those connections, we can create subcategories. We can create a weighting towards those subcategories. And as it calculates all those different chances, I mean, hopefully you would have multiple hidden layers to make more complex decisions. Essentially, the more neurons of decision making, and the longer that process, the more refined the thought process and the analysis is, and the more accurate it should become. Again, it also depends on accurate data. So, you have to go in there and weight some of those decisions nice and accurately to make sure that they're going to be particularly useful. Now, one of the big challenges that our particular example here really highlights is there's a lot of cultural influence on how we decide what food is or isn't. And that's a huge problem for computers, is while they can statistically analyze data, the data we give them is shaped by our sampling. If I only get recipes from Sweden, it's really only going to analyze things through the lens of Swedish culture. If I hand it then an example of Filipino recipes, it may have no idea what to do with them because it doesn't understand that change in culture because it hasn't been given the context for that culture. And so a huge issue with any AI system is the quality of the data set. So how do we actually build the information? How do we gather the information? How do we parse and interpret the information that we give it? The problem is, of course, culture is incredibly diverse and offers wildly different takes on things. So to us, yams are, a vegetable. But if you go to the Philippines, purple yam is like one of the most common dessert ingredients. So there's this big cultural shift there. In a single ingredient can mean totally different things depending on the culture. So we can see those differences radically affect how accurate an AI system is. This is just for food, but of course, if we interpolate, the fact that cultural differences can skew our AI, when we start thinking about other things and its application across the world, we can see much more dangerous things that could happen because of that. Here, we're dealing with dietary restrictions, cultural differences, religious restrictions. But when you start applying AI analysis to other aspects of life, behavior analysis for crime prediction, user preferences on social media, AI can be applied to anything. Market behaviors for investment firms, predicting claim adjustments for an insurance company. These are all things that AI are actually being applied to, but they have definite influences from culture and other very human aspects that may not be represented well within the data sets. So we need to be very aware of those influences and how they can influence the use of an AI, because if an AI isn't accurate, it's actually creating a barrier, right? Instead of just having human decisions, sure, that's a lot of work, but when you introduce an AI, you can alleviate all that human work, but if it's doing the wrong thing, you then have to do even more work to overcome those mistakes of the AI because the system is now adapted to not involve a human. And so overcoming those errors becomes an even bigger hassle and bigger burden to users. If an AI says your your insurance claim is fraudulent, how do you argue against an AI? It's not a human being. It can't make arguments. It doesn't allow for human involvement. So there can be a lot of challenges when we start switching our society over to AI-powered systems. If we're not creating systems for human collaboration and oversight, there can be enormous problems. But the value of AI is in removing human oversight so that everything runs more efficiently. So we're really at, we really have a tug of war between efficiency and ethics. But ideally, the more we think about these technologies, the more we understand these technologies, we can try and alleviate those problems. We do want to use the power of AI to make our world more efficient. Ideally, humans shouldn't be doing dangerous jobs. They shouldn't have to slave away doing menial tasks to, make the world function. We can use AI to make the world a better place, but there are dangers and we need to be aware of them. So by getting hands-on with technology like this, hopefully we can become more aware, more engaged, more understanding, and we can become informed citizens so that we can hopefully request, ensure, demand proper ethical use of AI in our society. So I believe that's all the time we have for today. I'll leave you with, there's some additional resources, of course. Kidsco Jeunesse are really some of the world leaders in talking about AI in classrooms. So we offer a number of workshops you can book with us to come into your classrooms to talk about AI, AI ethics, all sorts of different AI systems, as well as other coding workshops. So reach out to us. We always love hearing from teachers and other educators to engage more with the community. Let us know what you want to know about technology and what questions we can answer for you. So reach out to us. There's all our tags. Follow us and let us know what you think. And if you have any questions, chime in and we can answer things for a few minutes.
Kai, thank you very much. I see Kyla's watching the chat and we have some people typing in there. I'm going to stop the recording now. But you took us right up to the minute, which was fantastic. Some people are probably going to jump out to join other sessions.